All right, so here we have oil production. So it says the figure shows an estimate of the ultimate crude oil production recoverable from Earth. Estimate the two inflection points on the graph. Explain the meaning of the inflection point in the context of crude oil production. All right, well, so we're coming up here and then we're going to curve here. So maybe, I don't know, maybe about here would be our point of inflection. And because it looks symmetric, that would be about there on the other side. Now, can I draw a straight line down? Probably not. And not too straight. Now, what's that going to represent? How far is that? I'm not sure. But we can say maybe that would be 25, so maybe that's 23. So we might have the points of inflection of maybe, oh, I don't know, maybe it's close to 80 and 23. And our other one is, oh, maybe that was 5, so maybe, I don't know, 121 and 23 as well. Okay, so that might be our 2 points of inflection. Are they exact? Probably not. We're dealing with trying to guess on where the actual point is. We'd have to actually have the curve and then do our analyses as far as the first and second derivatives, and then that would tell us exactly where those 2 points were. Now, what does that mean? Well, it's basically going to be at this point, we have the greatest increase. And so we can say this is dealing with the recovery of oil was increasing most rapidly in whatever we said that was 80. And so 1980. Oops. And decreasing most rapidly in, and we said that was 2021 then. Okay, and so that would be what I would say. That would be the big key takeaway. Now, do we know anything else? I mean, that's the number of million barrels per year we're doing, but we really just want to say, okay, well, that's the most rapid increase. That's the most rapid decrease at those points. Okay, and that tells us what year they were. All right, so that's what I would do for this one. Okay, so here we have the ones where we actually have to start thinking about which one is the function, which one is the derivative, which one's the second derivative. So looking at A, now let's write these down. What do we have? Well, we're going to have well, we'll have a 0 at A at x equals A. We have a 0 at 0. We have a 0 at D and a 0 at F. Okay. It looks like we have probably at this point here at point of inflection here. So we have a point of inflection, x equals 0. And there might be another point of inflection somewhere around here. I would say probably closer to here. So to the right of D. Okay. Um, what do we have? We have tangent is equal to 0 at, and that looks like at a B and at C and at E. And so we can draw those horizontals. And then what that means is when that's going to be, if that's the function, then the derivative will have a 0 at that point. Okay, so that's going to be a key thing. So I think that's probably about all we can do there. What about B? Well, B, we have a 0 at x equals 0 and D, it looks like. Um, okay, and see these tangents, these are going to also be, the max min. That's another thing to look at, that as is max and min. So you have a min, a max, and a min. And so then here we have a tangent equal to 0 at around C. Not sure about any inflection points or anything else after that, but that's about all we have. So let's go to C. And so here we have a 0 at x equals b, and c and e. We have tangent equals 0 at uh, b. Oh, wait, tangent 0, not b, that's at 0. Tangent's at 0 and just past d. All right. And inflection points, there might be one, I don't know, somewhere in here, maybe around C or so. Inflection point at C, we'll say. It's roughly going to be there, or to the right a little bit. Okay. So now, which one is going to be the function? Well, if we have this going 0 and 0 and 0, so we need to find one that has 0 at B, C, and E. Okay, well, B, C, and E, well, that's going to be this one. So this could be the function, and this could be f prime. Now let's look at this one. We need to have a 0 at 0 and a 0 at past D. Well, here's a 0 at this, and here we have that. So that doesn't work so well. Let's see. We have a 0 here, so that would be a 0. 0 past D. Oh, okay, so yeah, that okay, well, yeah, that one I think what they're doing is they're going to call that the 0 here, so it's off a little bit. So maybe that's what that is. So maybe this could then be f double prime, or the second derivative. So if we do that one, uh, from here, that's going to give us a 0. That will give us a 0. Here we should have a max around C, or min, I guess, since we're going down. So that would be there. So that works. So I think, yeah, that's I think our thing. So A is equal to the function. B is equal to the f double prime, and C is equal to f prime. Okay, so I think what we have here works. And again, we pulled out everything we knew, and then we were able to fit it with what we had. All right, so let's stop there, and we'll come back for more.